So, chapter 3. There's an index on the left-hand side, making it easy to refer to material. What is an operator? And make sure that you know the difference between an operand and an operator. Operand is the thing on which operator operates. So if I say 3 plus 4, the plus is the operator and the 3 and the 4 are operands. Okay? Make sure that you know the difference between operators and operands. Now, there are many operators available, plus is 1, minus, etc. But then there are also some more complicated ones. Operators. Assignment is an operator, that is the single equal sign. And comparison is another operator, that's the double equal sign. Logical, those are the and or, and not. Binary, and unary operators. So let's just quickly say something about the difference between a binary and a unary operator. A binary operator takes 2 operands. 3 plus 4, plus is a binary operator, it takes 2 operands, 3 and 4. We also get unary operands in C#, which takes only 1 operand. Please give me an example.
Increment.
Yes, sir. Plus, plus. It's an increment. It takes a single operand. So, unary and binary operators. Here's a list of operators separated into categories. These are all, not all of them. Yeah. The plus sign. There's a plus and there's a plus. The same symbol used for 2 meanings. This is revision, Same symbol, and from the context we know now to which of the 2 operators we refer to. Same symbol, 2 different operators. String concatenation, when we read, normally when you get used to it you say plus, but actually I like to not use the word plus when I see the symbol for concatenation. I would say concat to distinguish, but sometimes we do say plus. In Afrikaans, what would concat be? You help me out? Shall I repeat that? In English, correct translation would be head to tail. Head to tail concatenation. On mekaar las. Right? It is not plus. Type conversions, etc. So those are typical operators. Operator precedence, the sequence in which operators are applied. Arithmetical operators, you read through this, make sure that you are familiar with all of this. Logical operators, etc. Bitwise operators, I don't think that you did this in the first year. You can read through it. It comes in handy sometimes. Comparison, assignment, conditional. Yeah, that one is very handy. I'm not sure if you used this before. Note that question mark there. Yeah, I think it is in the first year textbook. That question mark asks a question. Is A larger than B? True or false? If true, then that's a string and this is a right line statement. So the question is, what is being printed to the console? So if A is larger than B, that is printed. And if this is false, then this is printed. So we like to use that one instead of an if. You can, of course, always get away without that thing by just using an if. Access operator, as in datetime.now. Square brackets is used for arrays and array indexes. We have several types of brackets in C#, and we should always remember what the different brackets mean. There are three types that I can think of, and one of them is used for two purposes. The square type brackets is always used for indexing, as in arrays or lists. Then we have the braces, where we can encapsulate a class as there, and the brace is also used to denote scope. All right? So that first line in that block there is different meaning of the braces that we use it for when we denote scope. You are quite used to the scope one. When I write method, open brace, close brace, and everything in between. If condition, and then there's a scope. This condition applies to, or this if statement applies to a specific series of lines of code that you are familiar with. And then the third one, which is not here, is the angular brackets. It looks like a less than and a larger than sign, huh? Angular. Less than, larger than, and then something in between. We will get to that later. Angular brackets. For now, those typical kind of brackets. Make sure that we understand it. Let's run through this, skip the rest. Our timing's running out. Input and output into the console. And for the sake of examples, we like to work in a console window and not in a Windows Forms environment. In a Windows Forms environment, as in the plants example for next week, we have forms. And then input and output are done through text boxes and labels and message boxes and buttons and those things. Sometimes those form elements add overheads to a problem. And then we lose focus on what the actual problem is. So in order to focus on a specific problem, we like to work on a console window many times, so that we focus on the actual thing that we're busy with and don't lose track of things by bells and whistles. So the console window is important during programming, especially in complex environments when we want to test things. You can, what's there with us? I don't think that's anything that's you don't know. The conditional statement, the typical if, but there are other conditional statements as well. So if and if else, you know well, you know the switch case, you're supposed to. So make sure that we know what that syntax is. That's really, really treating you as beginners. But just go through this. Make sure that there's nothing, maybe information hidden somewhere that you did not know. Never ever. See if I can find an example. I never want to see the word true or false in a condition. I can't find an example now. But if I see a word true or false inside a condition, I'm not going to mark your work. That's one of the basic things that you should not do. So if we have a Boolean variable, let's say is tired, bool is tired is false, for example, and then you do some work and then you become tired and is tired turns to true, and then you want to check if the person is tired or not. So you say if is tired equals true, I close your project and I put it away, I don't do it. Is tired is a bool in itself. So it's if is tired. That's it. Got it? Don't compare with another bool. It's a bool in itself. So never ever put the word true or false inside the condition in an if statement, please. Else's, and of course you should be able to follow the logic of these logic operators. That's your switch case. Make sure that you understand the syntax, and you can do this. Sometimes one can forget the break, forget the default or something like that. You think doesn't work. Understand the basics about the switch. Loops. What is a loop? While condition. Again, never ever true or false in there. So you could say, for example's sake, while I'm tired, rest. And then you keep on resting until you're no longer tired, and then you go on with the rest of the program. So you don't say, while is tired is true, rest. You just say, while is tired, rest. Got it? And we have the loops that with a condition at the beginning, and we have a do-while loop with a condition at the end. And for all of these, we have the flow charts. So you can go through these examples. Some of these examples are maybe not as trivial as the others. So this specific example of the prime is an example that you might not find trivial, but you should be able to know that. The number is prime if it's divisible by only 1 and itself. So now we have a flag here, and our convention puts an is in front. Bool is prime is true, so we have this flag setting it to true by default. You step through all the possible divisors, and if you find a divisor that goes into it without a remainder, then this flag is reversed, its number or its value is changed, and then we write down a message. While loops do while. There's a do while loop with a condition at the end. Then there's another maybe non-trivial example. You should be able to, where's the code? Code. Yeah, there's one specific possibility of developing a factorial algorithm. Of course, we actually want this to be recursive. This one is not recursive. For each loop. For each is a loop that is limited but handy. Limited in that we don't have control over the loop. We don't have control over the loop counter. But if you really want to traverse every element in a list or an array, for each is handy. It says go through each one. But it has the limit in that if I have a list of 100 elements and only want to traverse number 20 to 80, then for each doesn't work, then I need a for. I can also not increment the counter by more than 1. So if I want to visit every second or third number, my normal for loop allows me to increment the counter by 2 or 3 or whatever, whereas for each says go to everyone, for each. But for each is handy if you really do want to do this. Then we visit each and every element in a collection, meaning an array or a list. Nested loops. You did a whole chapter on loops last year, and one of the examples was the nested loops, where you have a for inside a for, an inner loop and an outer loop. Printing a triangle. I'm going to stop here. I'm just quickly going back to my examples, which will be available on Blackboard. All these examples that we've just run through quickly now are available here. So there's, for example, a bool operator example, There's a for each example. There's a multidimensional array example. We will discuss arrays next week. No, not next week, Wednesday. But you can go through all these examples, and they are typical examples, and most of them are taken from NACOF. So you can just run this. You don't have to type the examples yourself. Of course, if I can take you back, to this, sorry, that's not what I wanted to do. There. Don't ever blame your teacher. Programmers learn by doing, not by listening. So whatever you did this morning, the past hour, was all in vain. You have to go back and do the thing and run the programs and check the examples in Visual Studio. That's the way we learn, not by sitting in a class and listening.